Okay, let's simplify the following expressions. Number one, we have square root of 20 over 64. So let's see, we know that 20 is 4 times 5 and 64 is 4 times 16. So this simplifies, the 4 and the 4 cancel out, and you're going to end up with square root of 5 over 16. You can separate the numerator and the denominator. And you notice that the denominator comes out of the radical. So square root of 16 is 4. And here's your answer. Square root of 5 over 4. Now number 2, we have square root of 12x to the 15 over 30x to the 14. Let's see, we have the number part. 12 is 6 times 2, x to the 15. And then here 30 is 6 times 5, x to the 14. The 6 and the 6 cancel out. So you're going to end up with 2 over 5 numbers. And we can use the quotient rule for exponents here. So we have x to the 15 over x to the 14. Remember, we have the same base, so we have to subtract. So you get x 15 minus 14. You guys know that this is 2x to the 15 minus 14 is 1 over 5. And the answer is square root of 2x over 5. Now, number 3, we are now taking the cube root instead of the square root. So whatever's inside whatever in the radicand has to be cubed before it can come out. So we notice that 8 is 2 cubed. So a cube root of 8 completely come out. So we can take it out right now. Cube root of 8 is 2. Now, writing the variables here, the variables that come out are the ones that with the power that is divisible by the index, or you can think about it as the power, the exponent has to be multiples of the index. You notice that here we have the case, it's the case here. X to the 6 is x square cubed, right? So the cube and the cube, so this is going to come out completely. And y to the 14, 14 is not multiple of 13, but so we have to do something about it. Instead of leaving it as y to the 14, we can write it as y to the 12 times y square. We chose y12 because 12 is divisible by 3, or multiple of 3. Okay? And we're going to be doing the same thing for z to the 5th power. 5 is not divisible by 3, so we need to go write it as x cube times, z cube times z square. Okay, again, we chose z cube because 3 is the same index, so z come out completely. Okay, so let's see. This can come out as is. The cube cancels the cube root. This is going to come out as you have it here, x squared. Okay, and then this is going to come out and this is going to come out. So you have cube root of, I can write this y to the 12 as y 4th cube. So 4 times 3 is 12. Okay, times y square, z cube, we're good. It's the same power. It's the power, the exponent is equal to the index, z square. So what happens here, this is going to come out completely. The cube cancels the cube root. It's going to come out completely as y to the 4th. And this is going to come out completely So cube root of z cubed is z. And then what's left inside the radical is y squared, z squared. And here's your answer.